So guys, we'll continue the discussion with respect to statistics, and now in this topic we are going to discuss about probabilities. Now probabilities are pretty much important because in machine learning, where you are actually doing some kind of classification algorithms, at that time you get your output based on probabilities, and based on a threshold value you decide like which class it may probably belong to. But in probabilities, we'll try to understand some of the important information that are important in terms of statistics. Over here, we are going to see what is the introduction, what is the additional rule in probability. For a mutual exclusive event, we are going to understand what exactly is mutual exclusive event. Then we're going to see non-mutual exclusive event, and there is also a multiplication rule, which is specifically for independent and dependent events. Probably this video will be divided into two parts. In this particular part, I'll try to show you the basic introduction to probability, and then we'll try to discuss about this additional rule for both mutual exclusive and non-mutual exclusive event. So let's proceed and let's try to first of all get a brief introduction about probability. So first I'm going to just define a probability. What exactly is probability? If you really want to define in front of a recruiter, you can just write it that it is about determining the likelihood of an event. Likelihood of an event or an experiment, anything. Now let's me take an example. Okay, suppose I toss a coin. So what are the possible outcomes whenever I toss a coin? I may either get head or tail. So if I say that what is the probability of getting a head when I toss a coin, obviously the sample space is 2. So I will basically divide by 2. And what is the possibility in one single toss that I may get head? It's obviously 1, right? So this 1 by 2, which is nothing but 50% probability, will definitely there to basically get a head. Similarly, if I go and basically try to find out what is the probability of getting a tail when I'm tossing a coin, it will also be 1 by 2, which is nothing but 50%. Let's take another example. Suppose if I am rolling a dice. What are the possible outcomes that I have when I'm rolling a dice? There are 6 different outcomes. Then suppose if I say that what is the probability when I'm rolling a dice, I'm actually getting 1. Let's consider that I'm denoting this 1 by a random variable x, because here is a process which can generate, just by rolling a dice, you can generate the 6 numbers. So what is the probability of getting x is equal to 1? Then now you should understand that what are the total number of outcomes that you can actually get. Obviously it is 6. And what is the outcome that you are looking at? 1. In a single toss of a dice or roll of a dice, you may either get 1 time 1 by 6, so it will definitely become 1 by 6. Similarly, you can actually find out the probability of x is equal to 2, then also it will be 1 by 6. So if I'm considering this is how you can basically calculate probability, right? Very simple definition. But just understand that this is the basic part of probability. But the most important thing is based on this additional rule. First of all, let's define or let's understand what is mutual exclusive event. So here I'm just going to write a topic which is called as mutual exclusive event. Mutual exclusive event. Now, what exactly is mutual exclusive event? Let me just define it. So I may say that two events are mutual exclusive if they cannot occur at the same time. Okay? If they cannot occur at the same time, right? This is a very simple definition. If I talk about non-mutual exclusive event, that basically means they can occur at the same time. Let me take an example. If I'm tossing a coin, right? If I'm tossing a coin, I can definitely, if I toss a coin, I may not get heads and tail at the same time, right? So the outcomes that we are getting out of tossing a coin is mutual exclusive because we cannot get head and tail at the same time. This is a perfect example of mutual exclusive event. Similarly, if I roll a dice At a time, I will not be able to get 1 and 5 or 1 or 6 at the same time. So that is actually mutual exclusive event. If I try to draw a Venn diagram, the Venn diagram will look something like this. Suppose I am tossing a coin. I may either get head or tail. There will be no overlapping, right? So in this particular case, suppose if I have given a problem statement, suppose I'm tossing a coin. Suppose I say, what is the probability of X? What is the probability of X? Or let me just write it in a much more better way. What is the probability from this specific event of getting a head or a tail? Then how do we define this entire formula? You know that this is entirely a mutual exclusive event. So you don't see any kind of intersection. So in order to get this, you can just write probability of head plus probability of tail. This process is basically called as additive rule. Additive rule for mutual exclusive event. So what this exactly is called is additive rule for mutual exclusive event. Now you go and calculate what is the probability of H. So probability of H is nothing but getting a head when you're tossing a coin is nothing but 1 by 2. Similarly, probability of tail is nothing but 1 by 2. So when you add this 1 by 2 plus 1 by 2, your answer will be 1. So what is the probability of getting a head or a tail in this kind of scenario? At that time, you will be able to see that you will apply an additive rule. Suppose if I take another example, okay, where I am rolling a dice. So in this particular case, the sample space, that the number of outcomes I may have is 6, right? So what is the probability of getting 1 or 5? Then obviously it will be probability of 1 plus probability of 5, because this is also a mutual exclusive event, and this is nothing but 1 by 6 plus 1 by 6, which is nothing but 2 by 6, which is nothing but 1 by 3. So this is basically the probability of getting 1 or 5, right? Now here we have pretty much focused in a mutual exclusive event. Now what about a non-mutual exclusive event? So let's take the next topic, non-mutual exclusive event. So this event basically says that two events can occur at the same time, right? Now let's consider some examples, right? Let's say that taking a card from a dice, from a pack of cards, or from the deck, you can actually say like this. If I'm taking out a card from a deck, let's consider that I get a king's card. Suppose if I'm getting a king's card, I may also get a kings of heart card, right? So two possible event is possible. I may either get a king's card, I may also get kings which is of a heart of kind, right? So here you can see that this is completely non-mutual exclusive. Two events can occur at the same time, right? So if I say that, what is the probability when I pick up a card from the deck? What is the probability of K or heart? What is the probability? I'm just making some heart shape. What is the probability if I take out a card from the deck, that card will be K or heart? Okay, this is also kind of additive rule, but understand over here when I'm taking out the card, so initially my total number of cards will be 52. If I'm taking out of a card, this card can be K also, it can also be K and heart. It can be the combination of both, right? So how do we apply an additive rule for a non-mutual exclusive event? So for this, the formula will be probability of K plus probability of heart, right, minus probability of K and heart. So what are the possibilities? If I go and consider a Venn diagram, I may get a card which will be specifically of K. I may get a card which will be specifically of heart, and I may get a card which will be of K of heart, right? Suppose this is K, this is heart card, right? I may also get a possibility that I'm getting K of heart, right? So guys, let's go ahead and compute this. So what is the probability of, whenever I take out a card from a deck, what is the probability of getting K? It is nothing but how many number of Ks will be there? There will obviously be 4 Ks, right? So 4 divided by total number of cards, 52. Then what is the probability of getting a heart symbol heart symbol card, right? So they are around 13 possibilities divided by total number of cards, right? And then 1 minus, we have over here K and heart, the combination of K and heart, right? Since this is a non-mutual exclusive event, 2 events can occur at the same time. So how many cards will be available like this? It will be hardly 1, and from the total number of cards it will be 52. Now once I go and compute this, this will be 17 by 52 minus 1 by 52, which is nothing but 16 by 52. So this is basically the probability of getting K or heart, right? And remember, this is again the additive rule for non-mutual exclusive events. Again, I'm going to write it over here. This is a non-mutual exclusive event, right? So this is just the understanding. What all we discussed over here? We discussed 2 things. One is the introduction to probability, and then the addition rule for mutual exclusive event and for non-mutual exclusive event, right? So these 2 topics, what is non-mutual exclusive event? 2 events can occur at the same time. So I have actually taken this particular example where I am taking a card from the deck and I'm saying that it can be a K, it can be a heart of K. So what is the probability of getting K or a heart, right? So both this combination, right? So in order to take this, I'm just going to use the simple additive rule, that is probability of K plus probability of heart minus probability of K and heart. Obviously I know how many number of Ks are there. 4 by 52 plus 13 by 52 minus 1 by 52. Finally I get 16 by 52. Very, very simple, very, very simple understanding. In the next part, I'm actually going to discuss about the multiplication rule. So thank you, and please make sure that you revise this if you're not able to understand.